Hey everyone, here's what I have that we're looking at today. We're going to be looking at polynomial functions, and really we're going to be looking at the graphs. We're going to be analyzing turning points in behavior and increasing and decreasing behavior. And we're going to be able to get all of that from the graph, and it's not actually going to be very difficult at all. But just to show you how it's done on a calculator. So here's our first problem, and I'm looking here. This is the polynomial I have, but I want to put in a standard form first. So that's going to look like x squared minus x plus 7. So everything's going to go down by degrees. Like this is a 1 right there, and then we have our constant term at the end. So that's a 2. Let me rewrite that because that looks horrendous. Let's see. Let's try that again, Mr. Hernandez. There, that's a 2. So x squared minus x plus 7. That's actually what we're going to go ahead and graph. So I have it up on my calculator. We're going to be graphing this. So x squared minus x plus 7. So I'm looking at this quadratic trinomial, and that's the graph I have. So I'm going to pull that onto our screen so we can continue to look at it. And if I'm looking here at this, it's only turning once. It's only turning right here. So I want to get that happening right there. And in order to find that, I see that it's at the bottom of my graph. So I'm going to be looking for a minimum. So second, calculate, and I'm going to find the minimum, number 3. When you're finding the minimum, the first question it's going to ask you is left bound. So you're going to move your cursor to the left of wherever your minimum is. You don't want to go too far. You want to keep it kind of near. And so we're going to hit enter right there. So see, my cursor is here. So I'm going to hit enter. And now it's going to say right bound. Where do I want to move the right boundary? And you might have seen this little arrow come up. So I'm going to move my cursor to the right of where that minimum value is. Alright, so right over there, that's fine. Now I see a second cursor coming. Let me just move that out of the way. So it's saying, like, look in between this boundary for the smallest value. Now for guess, it doesn't really matter. You could just click where you think like the minimum is, or you could just hit enter again. So I'll hit enter again, and we have to round this. So for that minimum value, and we're going to get a turning point. That's going to be that where it turns. Turning point. And that is going to be at 0.5, comma 6.75. Now in our future problems, we'll actually look at problems with lots of turning points, and you would write them all down. So that's going to be my turning point right here for this problem. Okay. If it turned more than once, if I had like a squiggly like that, so it would turn there, and it would turn here, then we'll keep going. But that's not what we're looking at, so get rid of that. Alright, so that's turning point. That's how you find it. If it was flipped the other way, then if it was flipped like that, then I'd be looking at a maximum value. I would have hit maximum instead of minimum. Alright, next thing I need to find is end behavior. So what's happening on the left side? So my graph is going to keep going like this. Like that. So what's happening on the left side? Well, on the left side, it's just going up. So how do I say that? Well, as x approaches negative infinity, so as x is going to the left, so as x approaches negative infinity, my y is going where? Well, my y value is it's going up. So up means infinity. So that's the left side, and as x approaches positive infinity, so what's happening on the right side now? My y's approach. Well, what's happening on the right side? So as x is approaching this way, my y values are going up. So my y values are going up to infinity. If it was down, I'd go negative infinity. So this part right here, those things are going to be the same. But it's always going to be we're focusing on the y values. That's what we worry about. So that's turning point. This right here, that's end behavior. End behavior. And now we want to find increasing and decreasing behavior. So I'm looking at this graph. Now it's basically like I'm riding a roller coaster. So I have this graph happening, and here I am. I'm going do. but I'm going down. So I'm going down. So I'm going from left to right. Always regress from left to right, and I'm going down. So that means I'm decreasing. Okay? And when I say I'm decreasing, okay, I am decreasing from negative infinity to that turning point x value. So that's why the turning point, we're always going to start off with the turning point. So I'm decreasing from negative infinity to 0.5. And then right there at that turning point, it turns and I start going up. So that means I'm increasing. Right, there's increasing. And so I'm going up from that turning point. So I'm increasing from 0.5. And it's just going to keep going to positive infinity. Now in the next problem, you're going to see how it looks when we have all these other things going on. You're going to have multiple decreasing and increasing. But for this problem, this is everything that we need to write. Like, this is the analysis that you need to get down to. Every time you see a problem, you're going to need to be able to just look at this and be able to get it down. Alright, so on to our next problem. Alright, so now we're going to move on to our next problem. And so let's look at it. We're looking at here, it looks like a bit of a beast, but it's going to be the exact same deal. We're still going to start by writing this in descending order. So I see a 2, 1, a 3, and then a constant term. So I'm going to put the x cubed first. Y equals x to the third. And then, just going straight down from there. Plus 2x squared minus 4x plus 8. Alright, so now I'm going to graph that. And, I'm going to graph this cubic 4-term polynomial. So x to the third plus 2x squared minus 4x plus 8. And graph it. Alright, looks like we actually have to do a little bit of work with our window here. So I'm going to change my y maximum. Let's see if 15 works. Alright, almost there. The reason I'm moving my y max up because I want to still get this turning point in there. So I'll just switch it over to 20. There it is. Alright, so we got everything here. And how many turning points do I have? If you're thinking 2, that is correct. So I have 2 turning points, and that's what I'll be using here. I have one here. And then one right there. So I want to find those turning points. So here we go, turning points. So looking here on the left side, it's at the top of this hill, so that's going to be a maximum. So I'm going to do second calc, and we're going to go to maximum. And again, move your cursor to the left side. Alright, so that's to the left, enter, move it to the right side. Alright, right over there. Alright, looking in between here, guess doesn't mean anything, just hit enter. And that's my guess. So I have a turning point at -2, 16. And as I said, this example, we have 2 turning points. So right here, I also have another one, a negative, or not a negative, sorry. It's at the bottom of a valley, so that's a minimum. So I'm going to do second calc minimum. There we go. And I'm going to move my cursor. Again, we want it to the left of it. So that's to the left of where that minimum value is. So hit enter. And then to the right of it. So to the right of where that minimum value is. Okay, there it is. Enter and then enter again. Alright. And the only thing I'm going to change about this is that it is saying 0.66666. You can round that, but we already know that that is 2/3. So I'm going to write it as 2/3, comma 6.52. Okay. Actually, yeah, I'm going to keep this as the decimals. If I'm going to do decimals 1 point, I'm going to keep them all decimals. So 0.67. Okay. So those are our turning points. What's the next thing we need to find? Well, we need to find end behavior. So looking here at the end behavior, you just describe what's happening on the left. On the left side, it is going down. On the right side, it is going up. So we just need to say that. So end behavior. IOR. Alright, there we go. So as x is approaching the left side, as x is going left, that's negative infinity. What are my y's doing? Well, we said they're going down. Down is negative infinity. Oh, I forgot my negative sign. Alright, there it is. Negative infinity. Now on the right side, as x approaches positive infinity, my y values are going where? Well, on the right side, they're going up. So we're going to say it's positive infinity. There it is. And behavior. Now, the last thing we need is increasing, decreasing behavior. So increasing, let's take a look at it. So it is increasing from the left side all the way to this turning point, and then it goes to decreasing, and then it goes up, up, up again. So kind of like a roller coaster. You're going up, you're going down, going up. Alright, so we're going to have to say those two increasing parts separately. So I want to say it's from negative infinity. And what is this x value? Well, that x value is this negative 2 right here. So the negative 2. Now, since I have another part that's increasing, I'm going to use a union symbol. And we're going to pick it up from this x value, which was 0.67. And it keeps going up all the way to infinity. So all the way to infinity. There it is. And that captures both of the parts that are increasing. Now for our decreasing side, it's only this part right here in the middle. Only that. So we need to say it is happening between those two x values, which is negative 2 and 0.67. And that is the decreasing behavior. It's decreasing from negative 2 to 0.67. So that's those three things for this problem. We have one more problem. I want you to check it out. It's not that bad. Don't worry about it. Do I have another one after this? No, I don't. Thank God. But this problem, you try it on your own and then check it on with us. So I have a y equals x to the fourth minus 3x to the third plus 3x squared plus 10. So it is a 4-term, fourth degree polynomial. Alright, so again, we're going to graph it. Actually, let me fix my zoom real quick. Alright, graph it and clear that out. X to the fourth power, 4. There it is. Minus 3x squared. No, that's to the third. 3. There it is. Thank you. Plus 3x squared. Yeah, I was reading that one. Plus 10. Yeah, then I'm going to have to mess with the window again. Let's just see how it turns out. Whoa. Well, nothing came out. Let me just see. I put that in correctly. Minus 3x cubed plus 3x squared plus 10. Alright, yeah. Zoom. Let's see. Window. Let's switch out my y maximum to 25. Let's really expand the top side. Do I got anything from here? Oh, there's stuff going on over there, and I got some weird humps going on here. So I'm going to have to zoom in on that area. So zoom in on that spot. Let's see. Move my cursor over to this area. What's happening over there? Okay. Wow. Well, what's happening here? So I see, like, is that really a turning point? Well, let's see. So zoom in again. We'll see if that's really a turning point by zooming in again. Maybe it'll... if it keeps going up, then that's not a turning point. But if it slopes down just a little bit, then this right here would be a turning point. That's why I'm zooming in again, just to see if it does. It looks like it just keeps going up. Yep, it just keeps going up. It never slopes down, so it's just going to keep rising up. All right, that's actually a point of inflection, but we're not talking about that. You don't talk about that till pre-calculus. Let me switch my zoom back out. And let's see, how did I do it? I switched my window to 25. And then I think I zoomed in. So yeah, I want to do that all again. Alright. So in fact, this time I only have one turning point, and that is right there. So I need to find that minimum value. So second calc minimum. You really got to pay attention to these graphs. So right there, that's fine, and over here to the right. Okay, enter, enter. Alright, that looks like 0. So calculator is telling me 0 right there. So I have a turning point. At 0, 10. The reason I know it's 0 is because this -7 part right here, this -7, it says e to the -7. That scientific notation basically is just moving it. It's a very tiny number, so we're rounding that off to 0. So turning point at 0, 10, and then we have end behavior. And it's going up on the left and up on the right. So as x approaches -infinity, so on the left side, my y is going up to infinity. As x approaches +infinity, on the right side, my y is going up to infinity. So that's end behavior. And lastly, we have our increasing, decreasing behavior. So increasing, so it's going up from here all the way to the right. So it's going up from up, 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 up. So since we're increasing there, it's at 0, and it keeps increasing all the way to infinity. There it is. And then it's decreasing. It is decreasing from here all the way down. Alright, so from -infinity, to 0. That'll be our decreasing behavior. So if you got that, that's awesome. I know this was a weird problem. We actually had to fix the window a little bit. But once you fix that window, it all ships out. So one thing you could do is hit zoom and fit. So zoom fit. That's going to be down here, zoom 0. And it the calculator find like the best size for you to see everything that's happening with the graph. So you can see here that it's actually going, it's still going down, 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 and then it just like slowly rises up on the right side. And that's exactly what we see when we had it zoomed in here. With zoom fit, the calculator will get all the best turning points and everything all in a nice size fit window for you. But that's how you work with polynomial functions. We analyze turning points, end behavior, and increasing and decreasing behavior. If you need more help, please don't hesitate to reach out. My name is Mr. Hernandez, and I'm always here to help.